Welcome to Summarize Science. Today, we're looking at a study that could revolutionize medical diagnosis by giving robots a sense of touch. Palpation, the medical term for feeling for lumps, is a centuries-old practice that is still vital for detecting diseases like breast cancer. In fact, a huge number of cases are first discovered this way. The problem is that human touch can be subjective, and it's very difficult to reliably track small changes in a lump over time. To solve this, researchers built a complete system for artificial palpation from the ground up. At the core of their experiment are these novel, modular breast phantoms. These are soft objects made of silicone and hydrogel that mimic the feel of breast tissue. They were designed with an outer shell and an inner insert, which could hold a soft silicone lump of a specific size and shape. This modular design allowed the researchers to create over 1,150 different configurations to train and test their system on. Next, they used a robotic arm with a special tactile sensor to systematically poke the phantom at 110 different positions. This process collected millions of precise force measurements. But here's the clever part. Instead of just training an AI to find the lump directly, they used a technique called self-supervised learning. The AI's task was to learn an internal representation of the object by trying to predict the force readings at one spot, based on a sequence of previous readings from other spots. To see how well the AI was imagining the inside of the phantom, the researchers also took MRI scans to get a perfect ground truth image. The results are genuinely impressive. From the scattered touch data alone, the AI model was able to generate a clear image showing the lump size and location, which looked remarkably similar to the ground truth MRI. This is far more useful and interpretable than a simple map of raw forces. But how does it compare to people? The researchers conducted a small-scale study where 16 human participants were asked to palpate the phantoms and detect if a lump had changed size between examinations. Amazingly, the AI system performed significantly better than the humans, achieving a much higher recall rate while having a lower false alarm rate. So let's recap the key points. The researchers built a system where a robot feels a soft phantom, and an AI learns about its internal structure. This AI can then generate a clear image of what's inside and is more sensitive than humans at detecting subtle changes. The AI's learned understanding was so detailed it could even tell apart the different outer shells based on tiny manufacturing imperfections not visible in the MRI scans. While this is still a proof of concept, it points toward a future of accessible and highly precise artificial palpation tools. Imagine a low-cost device that creates an objective, digital record of tissue that can be accurately tracked over time, helping doctors catch dangerous changes earlier than ever before. It's a huge step toward giving machines a sophisticated sense of touch for medicine. Thanks for watching Summarize Science.